The basic components of your system are a compressor, a condenser, an expansion device, and the cooling coil mentioned just a minute ago called an evaporator. A cooling medium called a refrigerant cycles between the components. By applying pressure to the refrigerant and removing the absorbed heat, the refrigerant changes from a gas to a high-pressure liquid. When the pressure on the liquid is released, the refrigerant expands and changes back into a gas. In the process of changing from a liquid to a gas, the refrigerant absorbs heat from its surroundings and cools the air passing over the coil. The overall cooling capacity of your house is measured in BTUs, or British thermal units. 1 BTU is the heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. Therefore, a rating in BTUs per hour describes the amount of heat the unit will remove in 1 hour. A system rated in tons represents cooling effect achieved by melting 1 ton of ice in 24 hours. To convert, 1 ton provides 12,000 BTUs of cooling in 1 hour. Of course, there are several variables that have to be factored in determining how much cooling your house needs, but the general rule of thumb is 1 ton, or 12,000 BTUs, is needed for every 550 square feet of structure. The capacity of your system can be checked by looking at the data plate on the compressor condenser, or might be found somewhere in the serial number. An air conditioning system needs to be properly sized or undersized, never oversized. Too large of a unit will operate intermittently, and the moisture in the air won't have a chance to condense, thus leaving humidified air. There are 2 basic types of systems used in residential structures: integral systems and split systems. An integral system is a single package unit and should be vibration mounted. These are usually installed in the crawl space or the attic with ducts projecting through the roof or exterior wall to provide air for the cooling condenser. It is less expensive than the split system, yet even with the vibration mount, this system is still noisy. Most houses have a split system where the compressor condenser unit is located outside in the rear or side of the house to eliminate noise. A house with a forced warm air system usually has the evaporator coil located in the furnace plenum and utilizes the furnace blower to move air through the coil. A home with a steam or hot water system will usually have the evaporator coil located in the attic, with a separate fan to move air through the coil. The small pipe connecting the compressor condenser unit to the evaporator coil is the high-pressure liquid line. The large pipe is the suction line for the low-pressure gas. The most important part of any air conditioning system is the compressor. This should operate continuously without any noise or squeaks. Unusual sounds heard, like straining, squealing, or grunting noises, denotes a problem that should be checked by a professional. The fan associated with the condenser should begin the same time as the compressor. After about 15 minutes of operation, place your hand over the fan. The air leaving should be warm, as the heat is being removed during the compression of the refrigerant. Air that is not warm indicates a problem with the compressor. After your initial check of the air, look at the large pipe attached to the unit. Touch it on an exposed section to make sure the pipe is cool. A pipe covered in frost indicates a deficiency in refrigerant. The air conditioning system will still be operational, but the operating efficiency will be greatly reduced, meaning you are spending more money than you should be. Remember that the air intake should be at least 1 foot away from shrubs or obstructions. The compressor condenser unit should be mounted on slab or blocks. Any uneven settlement can cause cracks in the pipes. There should also be an electrical disconnect switch nearby for servicing. The evaporator coil, also called the cooling coil, can be located in the attic, basement, or the furnace plenum. A coil in the attic will often have refrigerant lines entering the building at the attic level. In the basement or furnace plenum, the lines are generally much shorter and run directly to the structure. Forced warm air systems usually have their coils in the furnace plenum and can be verified if refrigerant lines enter the sheet metal casing. Below the coil will be a pan to collect condensation and plastic pipes. If possible, look at the plenum for rust or mineral deposits that have accrued. An overflowing condensation pan can damage the heat exchanger and needs to be corrected by a professional. When the unit is operational, listen for unusual noises or vibrations. When the evaporator coil is separate from the furnace, it will have a separate blower and is referred to as a blower coil. This unit should be vibration mounted with styrofoam, cork, or rubber pads. The pan condensate lines sometimes extend through the exterior wall or lower portion of the roof and terminate in the gutter. If the coil is visible in the attic, there should not be any frost buildup, especially with attic temperatures above 150 degrees. Recall that increasing the number or size of the attic vent openings can lower the attic temperature. After about 15 minutes of operation, the air coming through the registers should be at least 15 degrees lower than the temperature of the room. Failure to feel chilled air can be one of three things: an undersized system, low refrigerant levels, or poor insulation. Also, pay attention to the airflow itself. Is it low? This could be an undersized fan or the need to balance the register dampers. Icing on the evaporator coils or some other obstruction should also be suspect. As mentioned earlier, the location of the registers is key to proper air circulation. Ideally, the supply register should be near an exterior window or door, and the return grill should be on the opposite wall. The door to the rooms should be undercut to further allow air circulation. Ductwork will either be sheet metal or glass fiber material. All ducts that are in unfinished areas need to be insulated. By nature, glass fiber ducts are already insulated. Some sheet metal ducts have insulation within the actual duct. By simply touching the duct, a cool feeling indicates no insulation. Also, look for air leaks at the joints where ducts connect. These leaks can be sealed with duct tape.